Welcome back to Weather Club Wednesday. I'm excited for this week. It is Clouds Part 2. And if you haven't seen Part 1, you may want to put this one on pause and go back and watch Part 1 to get a baseline understanding of what we're going to talk about, because today it's more of the advanced clouds, things you don't usually see. And last week we ended on lenticular clouds, and I told you I'd tell you about it. Well, here we go. Lenticular clouds kind of look like UFOs. They're my personal favorite type of cloud because growing up in Long Island, New York, I didn't get to see them much because it's not a mountainous region. But here in California, when I've gone to the Sierra, I've seen them in person, and it's always exciting. So they're a variation of Serocumulus, Altocumulus, or Stratocumulus clouds, meaning they can happen at different layers of the atmosphere. So mountains disrupt airflow. Imagine wind going across a plane, then it hits a mountain, goes up, and then comes back down. And then it could bounce, go up, down. So when it goes up, that air could condense at that one point where it's over that condensation level and form that thin strip of cloud. That's the lenticular there. Then it goes down, it goes back up, so it can leave a trail of those clouds, and that's why we often see them. Pilots know to avoid flying in areas with lenticular clouds because it means that there's turbulence in the atmosphere with the wind going up and down. So this is what Altocumulus, Lenticularis, Duplicatus looks like. This is when you have them stacked on top of each other, and this happens in the Sierra. This picture is from our region of Northern California. So I think you might be able to understand why these are my favorite. They look so amazing. Next thing we're going to go over is fan favorite, Cumulonimbus, your standard thunderstorm cloud. So this is the tallest cloud we have. It goes all the way from the lowest part of our cloud deck up to the top where cirrus clouds are. They can hit the stratosphere, and that's what's happening in this picture. So the stratosphere is a very stable layer of the atmosphere above the troposphere, meaning that air has a hard time getting there. It doesn't rise through, it only sinks. So when it hits the stratosphere, it kind of spreads out over that invisible ceiling and creates an anvil. So you could find mammatus clouds associated with it, and you may even find shelf clouds too. If you don't know what those are, don't worry, I'm breaking them down right here. So cloud 9 is a term you might have heard before we get into mammatus clouds. So you might have heard someone say, "Oh, I love this, I'm on cloud 9, meaning I'm happy, I'm excited." Well, I want to tell you where that comes from. The International Cloud Atlas came out first in 1896, and it defined the 10 cloud types we went over in Clouds Part 1. Cloud 9 is the Cumulonimbus Cloud, and that is the highest cloud there is. So when someone says, "I'm on cloud 9, it means you're elated, you're so happy, you're as high as you can get. And that's where that comes from. A little trivia for you there. So this is a mammatus cloud. Notice these pouches that look like are falling from the clouds. These are beautiful to see in person, and this is a textbook example. It won't always look as clear as this. So what these are pouches of cool air that usually are in the anvil of those thunderstorms. So ice crystals can freeze in a process called glaciation, and those would sink out of the cloud because cold air is more dense than warm air and form in these little pouches. And they often signal that a thunderstorm is nearby. So severe weather doesn't come out of mammatus clouds, but they usually are around mammatus clouds. And this is what Altocumulus stratiformis mammatus looks like in Tulsa, Oklahoma. If you catch these during sunset, man, you are in for a treat. How about that? A great glow. And this is a shelf cloud, also known as Arcus. So this is the leading edge of a thunderstorm. Sometimes it forms when rain-cooled air meets up with warm and moist air out ahead of it, pushing that warm air up, and that warm air forms this shelf that you're seeing right here. If you see this pass overhead, there are a couple things you can expect. You can expect the wind to pick up and the temperatures to drop. You're going to get colder air, and it's going to be windy right in front of that thunderstorm. And this can look very impending and dooming. This is from Long Beach Island in New Jersey. And this kind of looks scary, this shelf cloud. And in this instance specifically, this could be a reason to be scared and start to seek shelter, because likely right behind this, there are downpours, windy conditions, and some thunderstorms. Another really cool cloud is called Asperitas. So this one is associated with Altocumulus and Stratocumulus clouds. So a lot of these, what I'm explaining, are features of clouds that can be applied to different types. So these are the two most common types. And overall, this is very rare to see. And what you're looking at here is waves up in the sky. Do you see that waviness pattern there? So it's as if you dropped a pebble in a pond. You'd see those ripple effects, right? That's the ripple there. Except in this instance, the pebble is a thunderstorm and the pond is the air. So if you drop a thunderstorm in a very calm environment, that's going to create a ripple effect. And if conditions are right, you get clouds that look like this. This is in Augusta, Georgia. See those rippling waves in the sky? It literally looks like the ocean is above us in this picture. And I've had the luck of seeing this in person, and it is breathtaking. So if you ever see this, you know it is Asperitas clouds that's causing it. And then if you like the waves, well, this one literally looks like waves. It's called the Kelvin-Helmholtz or Fluctus feature. So Kelvin-Helmholtz, two physicists that discovered this, and it's most common with stratus clouds. This form when winds move at different directions at different layers in the atmosphere. So it's rare and short-lived, and they occur mainly on windy days, as you can expect. So here's another example of it in New Zealand. You see each wave of clouds moving up here? Pretty amazing, right? So it comes from, well, wind in different levels, going faster here and slower here, causing that overshoot of clouds up top. This one is pretty rare to see too, but whenever anyone does see it, it usually makes the news. A hole punch or cavum cloud. This is most common in Altocumulus. However, this cloud right here that you're seeing, this is Serostratus or Serocumulus, it looks like. So it occurs when cloud droplets transform into particles, a process called glaciation that we already talked about. So ice particles, they literally fall out of the sky because they're too heavy, and it creates this hole punch feature. So this can happen on its own, or it usually happens when an airplane flies nearby and it cools off some of the air particles and causes the process of glaciation. It causes some of those ice particles to form, and it creates this ripple effect, this chain effect. So other particles around them start to dry up too and form into ice and drop. So this happens all over the place. This picture is from Oakland, California. And these clouds are Altocumulus clouds, so we call this Altocumulus fluctus, or a hole punch. And now I want to tell you about something that's pretty rare. I've never seen this. I don't know if I ever will in my life. And this one kind of counts as a cloud, but it's very unique. It's called Noctilucent. So all the clouds that we've been talking about, all the weather that I forecast for, happens in the lowest layer of the atmosphere, called the troposphere. But these clouds are actually above the troposphere. They're above the stratosphere, and they go up even higher in the atmosphere. What happens is, it's in the mesosphere when water vapor freezes around specks of dust from incoming meteors. So this is why it's not too common, and it's only visible during dawn or dusk. So let's say you're standing here, and the Earth is curved, right? So if you're looking over the horizon up, you could see the cloud. So this is the observer in this instance, and you look up towards space. The sky's largely going to be dark, but you'll see some wave-like features in the clouds. Looks like this. So this is a Noctilucent cloud. It's a scene from Germany. And one day I hope I can see something like this, because it would be a marvel, but I'm not going to hold my breath. But if you're ever at dawn or dusk and you see some clouds that look kind of like cirrus clouds but not quite, it's a chance that they're Noctilucent. All right, it is time for a quiz with your favorite quiz partner, my friend and co-anchor, Pedro Rivera. Pedro, welcome.
Hi, kids.
You've been taking notes?
I've been taking notes.
You ready to go?
Yeah, I feel pretty good.
All right, let's step to the side and let's get this one started. First question. So you know what cloud this is, right? We just talked about the hole punch, right?
Yeah.
So what cloud type is the hole punch punching through? What do we got here?
That's a good, what kind of?
This goes back to clouds part 1.
This goes back to clouds part 1.
So tell me what you're seeing here. We can talk this through.
All right, I'm seeing a lot of clouds, a lot of bunching of clouds. I was thinking Altocumulus is what I was thinking.
And I think that's a pretty good guess. The answer, Pedro? Altocumulus. He's 1 for 1.
1 for 1.
So yeah, you're seeing these little soft cotton ball-like features, but they're not low enough to be cumulus clouds, a little bit higher up in the atmosphere. Altocumulus. Well done. Pedro's off to a hot start. Hopefully you are at home as well. If you see this cloud,
yes,
what other cloud is usually nearby? This is multiple choice. Is it A, cirrus, B, nimbostratus, C, cumulus, or D, cumulonimbus?
That's interesting. I'm going to go with cumulus.
Okay. Do you want to pick something else, maybe?
Yeah, cumulonimbus.
Okay,
Cumulonimbus.
so Pedro's going with D.
D.
Lock in your answers
Not
at
C.
home. The answer is D, Cumulonimbus.
I knew it was one of those two.
So we talked about what cloud this is. These pouches. Do you remember what they're called?
Yeah, I remember the pouches. Give me 1 second.
Okay.
I have it here somewhere.
Okay.
But
do you need more time? Do you want me to come back to you?
No.
Okay.
I think you got it.
Okay.
I think you got this one.
Pedro knows. We all know, of course. It's mammatus clouds.
Mammatus, that's my favorite because the protrusions in the clouds.
Yes. So this is mammatus clouds. Usually happen in the anvil of cumulonimbus clouds.
Right.
Thunderstorms are nearby.
Soft air is often.
Soft air, cold air sinks down from the cloud. Very good.
Thunderstorms are nearby.
Good job, home.
Watch out.
All right, we got this one now. Where's the wind blowing fastest in this Kelvin-Helmholtz cloud? Would it be here or here?
I think up top because down here it's slow, up here fast.
Very good, Pedro. He got this one right, and hopefully you got this one right at home too. So with a fast wind up top, that overshoots the top of those clouds and makes those waves sometimes when the conditions are right. All right, what should you do if you see this cloud? Pedro, first of all, what cloud is this?
This is a lenticular cloud.
It's a lenticular cloud.
Kind of looks like a UFO, often stacks just like you see here.
All right, should you A, call the police and report a UFO? B, take a picture and send it to Adam?
Okay.
C, not fly a plane in this area? D, B and C, E, all of the above.
I'm gonna go with D. I don't think you should call police because they have bigger things to worry about than the clouds. You should send a picture to Adam because it's his favorite cloud and he will love it. And second, I mean, planes know there's a mountain nearby, there's a lot of turbulence.
Yes,
that is an issue for planes.
That's the most important part. Air high five, man. Good job. All right. Well done, Pedro. You passed this quiz. Not bad. So we're going to thank you, and thank you to everybody at home who took this quiz with us. Pedro, we'll clap you out here. Good job.
Bye, kids.
All right, see you later. And the rarest of all clouds before I go, only seen once ever, is called the shark cloud, the hungry shark cloud right here. It's going for this little one there. So obviously that's just some cumulus clouds that end up looking like a shark. But thank you to whatsthiscloud.com. Great resources for learning about clouds. They have pictures, they have all this information about what clouds form in what situations and how to identify them. And that's it for Clouds Part 2. You're now an expert. We're on Fox 40 News every Monday through Friday morning, 4:30 to 10 a.m. Tune in. Hope to see you there. Next week, we'll have a new topic.